Okay, Wildcat. Today we're going to journal page 45, solving quadratic inequalities. Solving quadratic inequality steps. Step 1, rewrite the inequality with 0 on the right side. Step 2, solve the related quadratic equation to find the critical values of the quadratic inequality. Step 3, substitute the smallest critical value, abbreviated SCV, found in step 2 into the quadratic inequality and then simplify the quadratic inequality. Step 4, substitute the largest critical value, abbreviated LCV, found in step 2 into the quadratic inequality and then simplify the quadratic inequality. Step 5, choose an x value between the critical values found in step 2. A hint, use x equals 0 when you can. Step 6, substitute the chosen x value from step 5 into the quadratic inequality and simplify the quadratic inequality. Okay. Step 7. If the x value between the critical values is not a solution to the inequality and the critical values are not solutions to the inequality, then the solution set inequality is x such that x is less than the smallest critical value or x is greater than the largest critical value. If the x value between the critical value is not a solution to the inequality and the critical values are solutions to the inequality, then the solution set to the inequality is x such that x is less than or equal to the smallest critical value or x is greater than or equal to the largest critical value. If the x value between the critical value is a solution to the inequality and the critical values are not solutions to the inequality, then the solution set to the inequality is the small critical value, and that should say x such that the smaller critical value is less than x, less than the large critical value. If the x value between the critical value is a solution to the inequality and the critical values are a solution to the inequality, then the solution set to the inequality is, again, that should say x such that the smaller critical value is less than or equal to x, which is less than or equal to the larger critical value. Okay, go ahead and finish up your notes. All right, now let's take a look at the examples. All right, so step 1, we're going to set the right side to be 0, so we're going to subtract 25 from both sides. So now we have x squared plus 1x minus 30, and we're going to go ahead and set that equal to 0. Okay. All right, to find the critical values, we're going to try to factor. So parentheses equal to 0. We know x and x makes x squared. Now we need to find all the numbers that multiply to give you negative 30 and combine to be 1. So we know that negative 1 times 30 is negative 30. Negative 1 plus 30 is 29. Okay, that doesn't work. All right, so now let's do negative 2 times 15, which is negative 30. Negative 2 plus 15 equals 13. That's not it, but we're getting closer to 1. Okay? And it's a little bright. Let me try to adjust that. There we go. All right, so now let's try negative 3 times 10 is negative 30. Negative 3 plus 10 is 7. Getting closer to the 1. All right, so now negative 4 doesn't work. Negative 5 times 6 is negative 30. Negative 5 plus 6 is 1. So we have our negative 30, we have our 1. Okay, so our factors are x minus 5 and x plus 6. All right, so we're going to set those equal to 0. So x minus 5 equal to 0. X plus 6 equal to 0. We add 5 to both sides. So x equals 5. Okay, and then subtract 6 from both sides. X equals negative 6. All right, so let me get my steps out here and read those. So we did step 1. We wrote the inequality with 0 on the right side. We solved for the related quadratic on the critical values. Okay, so now we need to figure out which one's the small critical value and which one's the large critical value. Well, -6 is smaller than 5, so the small critical value equals -6, and the large critical value equals 5. Okay, so now step 4 says substitute. Oh, I'm sorry. Step 3 says substitute the small critical value found in step 2 in the quadratic inequality. So we're going to substitute this into here. Okay, so that's parentheses -6 squared minus 6 minus 5 greater than 25. Well, we can get this number by using Desmos. So let's go to Desmos. And we want scientific calculator. All right, so now we're going to do parentheses -6 squared minus 6 minus 5, which is 25. So what we're saying is that 25 is greater than 25. That's a false statement. So we know that this small critical value is not included. Okay, now let's do the largest critical value, equals 5. So we're going to plug that into the inequality. So that's 5 squared plus 5 minus 5 greater than 25. Okay, so let's put that at least the left side into Desmos. So 5 squared plus 5 minus 5 is 25. And 25 is not greater than 25, so that's a false statement, so they're not included. Okay? So now we need to choose an x value between the critical values. Well, 0 is between -6 and 5, so let's do that. Okay? So now we're going to plug 0 into here. So then use x equals 0. Okay, so now that's 0 squared plus 0 minus 5 greater than 25. Okay, so well, that's -5 greater than 25, which is a false statement. Okay, so what we have is right here. Okay, if the x value between the critical values is not, that's what we have, and the critical values are not solutions. So we're going to use this format. Okay, so we have x such that x is less than -6 or x is greater than 5. Okay, go ahead and finish up example 1. All right. Let's take a look at example 2. All right. First step is we're going to set the right to be 0. So in this case, we're going to add 4 to both sides. Okay. So then we have -3x squared plus 3x plus 6, and we're going to set that equal to 0. Now, in this case, we can divide everything by -3. Okay, well, -3 divided by -3 is 1, so that's 1x squared. 3 divided by negative 3 is a minus 1x. 6 divided by negative 3 is negative 2, and that's equal to 0. Now we can factor. If we know 2 parentheses equal to 0, we know x and x make x squared. Now we need to find all the combinations that multiply to give you negative 2 and combine to be negative 1. So 1 times negative 2 is negative 2. 1 minus 2 is negative 1. We have our negative 2, negative 1. That means our factors are x plus 1, x minus 2. Set them equal to 0, so x plus 1 equal to 0, x minus 2 equal to 0. Subtract 1 from both sides, x equals negative 1. Add 2 to both sides, x equals 2. So our small critical value is negative 1, and our large critical value is 2. Now we're going to plug negative 1 back into the equality, so that's negative 3, parentheses, negative 1 squared, plus 3 times negative 1, plus 2, less than or equal to negative 4. All right, so let's go to Desmos. So negative 3, parentheses, negative 1 squared, plus 3 times, I'm going to put that in parentheses, negative 1, plus 2, which is negative 4. Well, negative 4 is less than or equal to negative 4. That's a true statement. All right, now we're going to test the large critical value. So we're going to plug 2 into the inequality. So negative 3 times 2 squared plus 3 times 2 plus 2 less than or equal to negative 4. Okay, let's go ahead and plug that into Desmos. So 2 squared plus 3 times 2 plus 2 is negative 4. Well, negative 4 is less than or equal to negative 4, so that's a true statement. Now we need to pick a value between the small critical value and the large. Well, 0 works in this case. 0 is between negative 1 and 2, so we're going to use x equals 0. We're going to plug that into the inequality. So negative 3 times 0 squared plus 3 times 0 plus 2 less than or equal to negative 4. Okay, well that's 0, that's 0. We have 2 less than or equal to negative 4. Well, that is false. Okay, so going back to our notes, in this case, if the x value between the critical value is not a solution, that's true, and the inequality critical values are solutions, which is true, we use this format. Okay, all right, so x such that x is less than or equal to negative 1, or x is greater than or equal to 2. All right, go ahead and finish up example 2. All right. Let's take a look at example 3. So we're going to subtract 7 from both sides. So you have x squared minus 2x minus 7 equal to 0. Okay, so now we're going to factor. We know 2 parentheses, x and x. Okay, now we ask ourselves, what numbers multiply to give you negative 7 and combine to be negative 2? Okay, so let's try 1 times negative 7 is negative 7. 1 minus 7 is negative 6. Okay, that doesn't work. 2 doesn't work. 3 doesn't work, 4 doesn't work. 7 times negative 1 is negative 7, and 7 minus 1 is positive 6. Well, there are no numbers that multiply to give you negative 7 combined to be negative 2, so we'd say that this is not factorable. Okay, so now we're going to need to solve using the quadratic formula, where A equals 1, B equals negative 2, and C equals negative 7. Okay, so then X equals negative B plus or minus the square root of B squared minus 4AC divided by 2A. All right, so X equals negative B, which is negative 2, plus or minus the square root of parentheses negative 2 squared minus 4 times 1 times negative 7 divided by 2 times 1. Well, X equals a negative times negative is a positive, so that's 2 plus or minus the square root, and let's go ahead and put that into Desmos, just the radicand. So we're just going to put in parentheses negative 2 squared minus 4 times 1 times negative 7 is 32. Divided by 2. Okay. Now we need to see if we can reduce the square root. So that's X equals 2 divided by 2 plus or minus 1 divided by 2. And let's see if there's another way we can write the square root of 32. So I'm going to add a tab. I'm going to Google search Desmos, graph, and table. Click on function tables. All right, and then we want to find all the perfect squares that divide into 32. So we're going to do 32 divided by x. All right, now we know 1 is a perfect square, but that doesn't help us, so let's go to 4. 4 works, okay? But let's see if there's another perfect square. 9, it doesn't work. 16, ooh, 16 works the best. 16 and 2, that's as simplified as it's going to be. So we can write this as the square root of 16 times the square root of 2. Okay? So the square root of 16 is 4, so we have x equals 2 divided by 2 is 1, plus or minus 1 divided by 2 times the square root of 16 is 4 times square root of 2. All right, well, 4 divided by 2 is 2, so then that's x equals 1 plus or minus 2 square roots of 2. Okay, now we need to see which one of those is the small critical value and which one's a large critical value. So you don't need the function table right now. Actually, I won't leave that. I'll leave that there. So let's just see. 1 plus the square root of 2 is 2.41. And 1 minus square root of 2 is negative. So the small critical value is approximately, oh, actually, you know what? Let's put the exact first, is equal to 1 minus, ooh, I think I messed up. Let me see, hold on. Glad I didn't, yep, I forgot to put the 2 right here. Okay, doesn't affect which one's small or large, but so that's 1 minus 2 square roots of 2. That's a small critical value. And then the large critical value is equal to 1 plus 2 square roots of 2. Okay, so now to plug this in to the inequality. That looks like it's difficult, but since we're using Desmos, we can make it easy. So, parentheses, 1 plus 2 square roots of 2 squared minus 2 parentheses 1 plus 2 square roots of 2. Okay, so we have, when you do that, when we test a small critical value, and we did 1 plus 2 square roots of 2 squared minus 2, and make sure I didn't forget the 2 on that one. Nope, did. All right, so 2 times 1 plus, ooh, sorry, I put it in Desmos correctly, but I'm putting it wrong here, but now I've got that. 1 minus 2 squared to 2 less than 7. And you want to check yourself sometimes. So should have put in minuses right there, but nonetheless, that's 7. Okay, so 7 is not less than 7, so that's false. Okay, now we need to test the large critical value, which is 1 plus 2 square roots of 2. Okay, so that's 1 plus 2 square roots of 2 squared minus 2 times 1 plus 2 square roots of 2 less than 7. So really all I have to do is put a plus sign right here, not an equal sign, plus, and a plus, and we get 7. Well, 7 is not less than 7, so that's false. Okay, so now we can pick 0 again, so x equals 0. All right, so now that's 0 squared minus 2 times 0 less than 7. Well, that's 0 less than 7, which is a true statement. Okay, so going back to our notes, okay, so in this case, it's right here. Okay, so if the x value between the critical value is a solution, which is a solution, and the critical values are not solutions, we use this format right here. Okay, so this is x such that 1 minus 2 square roots of 2 is less than x, which is less than 1 plus 2 square roots of 2. All right, go ahead and finish up example 3. All right, example 4. Solve the inequality. So we need to subtract 2x from both sides. Okay, so then we have negative 1x squared minus 2x plus 6, and we're going to set that equal to 0. We're going to divide everything by negative 1. So the negative 1 divided by negative 1 is 1x squared. Negative 2 divided by negative 1 is a plus 2x. 6 divided by negative 1 is minus 6, equal to 0. Okay, now we need to figure out all the combinations that multiply to give you negative 6 but combine to be 2. Well, we know that negative 1 times 6 is negative 6. And then negative 1 plus 6 is 5. That doesn't work. Now let's try negative 2 times 3 is negative 6. Negative 2 plus 3 equals 1. Well, that's all the combinations that are possible, and none of them will give you a combination of 2, so this is not factorable. Okay, when it's not factorable, we use a quadratic formula. So A equals 1, B equals 2, and C equals negative 6. Okay, the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4 times ac divided by 2a. Okay, so x equals negative b, which is negative 2, plus or minus the square root of 2 squared minus 4 times 1 times negative 6 divided by 2 times 1. Okay, so then x equals negative 2 plus or minus the square root, and let's go ahead and use Desmos to get that number. So 2 squared minus 4 times 1 times negative 6, which is 28, divided by 2. So we have x equals negative 2 divided by 2 plus or minus 1 divided by 2 times the square root. Let's see if we can simplify the square root of 28. So over here, instead of 32 divided by x, let's do 28. All right, so 1 works, but it doesn't matter. 4 works, and I believe 7 is a prime, so that's as reduced as it's going to be. So we can make that as the square root of 28 is square root of 4 times the square root of 7. Okay, so then that x equals, that becomes negative 1 plus or minus, the square root of 4 is 2, so that's 2 divided by 2 times the square root of 7. Well, 2 divided by 2 is 1, so that's x equals negative 1 plus or minus 1, but we can just write that as the square root of 7. All right, we need to figure out what the small critical value is and the large critical value. So let's plug those into Desmos. So we have negative 1 plus square root of 7, okay? And then negative 1 minus the square root of 7. So this is the small, that's the large. So the small critical value is negative 1 minus the square root of 7, and the large is negative 1 plus the square root of 7. Okay? So now we need to plug this in. So that's parentheses negative 1 minus square root of 7 squared plus 6 greater than or equal to 2 times negative 1 minus square root of 7. Okay, so we're going to need to do the left side, then do the right side. Okay, so let's do that now. Okay, so parentheses negative 1 minus the square root of 7 squared plus 6, okay, and then 2 parentheses negative 1 minus the square root of 7. So what we're saying is, let's just round to one decimal place. So 19.3 is greater than or equal to negative 7.3. Okay, well, that's a true statement. Okay, now we need to test the large critical value. So that's parentheses -1 plus the square root of 7 squared plus 6 greater than or equal to 2 times -1 plus square root of 7. Okay. And so really, all I have to do is come over here and change this to a plus sign and this to a plus sign. And we see that we have 8.7, which is greater than or equal to 3.3. Okay, that's true. And again, I believe we can test x equals 0. And let me see. Let me go back over here and put in -1 minus square root of 7 and -1 plus square root of 7. Yes, 0 is between these numbers, so we can test at 0. So x equals 0. So we have -0 squared plus 6 greater than or equal to 2 times 0. And I'm going to have to move this down. So I have space 2 right here. So that's 6 greater than or equal to 0, which is true. Okay, and so from our notes, if the x value between the critical values is a solution to inequality and the critical values are solutions to inequality, we use this format. Okay, so x such that the small critical value, which is -1 minus the square root of 7, is less than or equal to x, which is less than or equal to -1 plus the square root of 7. All right, go ahead and finish up your examples and have a wonderful Wildcat day.